All right, let's get started then. So I will start by sharing my screen. Okay, make sure that's working. I joined on my phone this time so that I can make sure that things are working and that I can see the chat as well more easily. Okay, so there's a couple announcements for the course. The two announcements are, the first one being that the Pctf groups have been created. So I don't exactly know. Does anyone know, have you like received an email or have some sort of event occur inside of Coursera that says like, hey, you're part of a team? Does anyone know?
I got a Slack invite.
You got a Slack invite. Okay, so that's something. Is that the only indication?
Too. You can see from from Coursera that you've been added to the team under teamwork.
Okay, perfect. Okay, great. So under, we'll add that as a note. Under teamwork, see your team. Okay, and that probably would be this tab.
How many teams are there?
Yeah, okay. That is a good question. I probably have some way of figuring that out. I don't exactly know though. I can, oh, so someone says they're team 26, so.
I'm 34, so it's at least that many.
Yeah, I forget, I think I was told how many people were in each team. Is it like, are like 4 people in your team or is it 6? I don't remember.
There are 6 in my team.
Okay, 6. I think most teams have 6, but a couple of groups are different. I don't know, but around there. And if your team size isn't the standard, we will account for that in whatever way seems most fair, makes the most sense. So I wouldn't worry too much. Okay, but yeah, I think almost all of the teams have 6 people. Okay, so that covers that announcement then. And then the second thing, I don't exactly know on the second one either. So sorry for being a little confused on some of these announcements, but the second one, I believe I was told like a few weeks ago, so that's why I'm telling you now and not entirely sure, that the ProctorU system for taking exams, I believe you're supposed to at some point like schedule a time for an exam. Does anyone know if that's true? Has anyone used?
That is definitely true. I scheduled mine before the class actually even started.
Oh, that's awesome. Okay, yeah. So if anyone hasn't scheduled your exam times, I would definitely encourage you to do that. I know that my Coursera point of contact definitely told me like, hey, this is like something people should do. Because my understanding is that it like sometimes can fill up, get like crazy, get busy. I'm not entirely sure of this situation, but I would definitely encourage people to go and register. It looks like, yeah, you can register for both the midterm and final exams. I would do that as soon as possible to make sure that you're not left in some headache situation. Okay, so that is those 2 points. And then, so I guess the thing to see here is what is coming up. So we can see, I guess on the grades tab, the bandit assignment was already past due. So hopefully everyone got a chance to do that and hopefully is are a bit more comfortable with Linux if you haven't used Linux in the past. Of course, as I'm sure you're all aware, the current main assignment that's pending is the backdoor web server. And then following that will be crack the password and the reflector assignment. As well as those these programming assignments that are coming up by, I guess, the end of the month for all 3 of these. There's also the Pctf team project proposal. So I would definitely encourage everyone to meet with their teams. It sounds like there were Slack invites sent, so presumably you're able to communicate with your teams on Slack, and then you go from there, maybe do Zoom calls or whatever makes the most sense for coordinating your team activities. To think about the Pctf and work on creating your team project proposals. So those are kind of in the short-term future of what's coming up with this class. Okay, so I guess before we start, does anyone have any immediate questions that maybe we can dive straight into from the assignments or maybe content or really whatever surrounding this class?
Well, the assignment in the web server backdoor is, I think, like for me, it was about my skill level. I haven't touched C in a long time, and I still haven't resolved it. I've been working on it for about 5 days, and estimated time is about 5 hours. So I'm still work in process.
Yeah,
Work in
so
progress.
I don't know how the time estimates were estimated. I would probably say if you're like very comfortable using C and that you're familiar maybe with HTTP, that 5 hour time estimate makes sense. If, like you said, you've spent a while since you've worked with C, or maybe some of your programming skills are rusty or whatever, that time estimate certainly might not be accurate, unfortunately. Did you have any questions in particular about the web server, or yeah?
Well, I'm stuck on the last 2 secret tests, and I see that my program does pass the test. I think I know which one it is, related to path, but the grader doesn't like it, and I don't know how to resolve it.
So what do you mean it passes the test, but then the grader doesn't like it?
Like I wrote a code that basically displays what client is requesting in terms of absolute path, and well, grader, it doesn't pass the grade in last 2 secret tests. Like, and my question was like, if I don't complete remaining 20%, and leaving this assignment at 80% completed, how was the effect of it, moving forward?
So your question is, if you don't complete the last 20%, basically, how does that impact you moving forward? Is that the
correct? Yeah. Is there going to be some
Okay.
other assignments that depend on the remaining 20%, or it's not a big deal?
I would say that there's not necessarily like a future assignment that directly depends on solving that. I definitely encourage you to solve it, but I guess if I guess if it's proving to be challenging, maybe not worth the amount of effort or whatever reason you don't solve it, I would say that the future assignments don't directly depend on those concepts. So all of these assignments are pretty different. I don't think any of them really depend on one another. So for instance, I think I talked about it in the last one, but I'll quickly go over as an overview. Crack the password will be, you get a binary and you have to reverse engineer it. So I would say that's definitely different. The reflector assignment, I don't know if you can use any language you want. Maybe you can. You can definitely use like Python, for instance, and that will be dealing with networking, basically trying to do ARP spoofing and IP spoofing. The binary hacking assignment will be like 10 binaries that you have to exploit. And then the web hacking assignment will be 10 websites that you have to hack. So none of them directly depend on that information. So yeah, I guess use that information however you want. In terms of those 2 test cases, I know I said on the discussion group that you can find the information in RFC 2616, like the rest of the information. From the few submissions that I've looked at that weren't meeting the secret test cases, the thing that they were missing was definitely in this section 5. So if you like just take this section 5 and copy it into your text editor, do that. And if you just look for like must, and you just like go through all of these musts, make sure like, if you're missing these test cases, there's a good chance you're missing something on one of these musts. So that's kind of, I guess, my hint for that. Certainly for the first secret test case. Okay, so I see that there's a question in the Zoom chat about when will the usernames, passwords, IP addresses, and port be released for the binary hacking and web hacking assignments. So that's a good question. So binary hacking / web hacking details. The short answer is basically that the assignments need to be spun up on a server. So I, at some point, will need to create the servers, import everyone in the class into that so that they're able to access the server. As for a time estimate on when that will happen, my hope is that I will get that certainly. Okay, so the first thing let's do is the binary hacking. My hope is to get that spun up this weekend and get the credentials out to everyone this weekend. But I can guarantee that at the latest, it will happen by the end of this month. So that will give people, I believe, at least like 2 weeks to work on that. Let's see, when does that due? This is the 14th. So if I get it done by the end of the month, it will definitely give you 2 weeks. But my hope is to get that done this weekend to spin that up for the binary hacking assignment. And then the web hacking assignment is a similar requirement that I need to spin up a server to get that going. And I will shoot to get those both done at like the same time with, I guess, priority on the first one. And when I get the details out, I'll send it to you. But I will guarantee at a minimum for both those assignments, you'll have at least 2 weeks. Yeah, so ideally this weekend, guarantee 2 weeks before due. Okay, let's go with that. Are there any more questions?
Yeah, I do have a question actually.
Okay.
So first, like if you went to the grade section and on Coursera, I don't know if I'm doing my calculation correctly or not, but the individual assignments end up like if you summed all of them, you will have 70% of what you need to pass. And the group assignment also have like 50%. So that ends up to 120%. Am I correct?
I am not sure. So we've got 3, 4, 5, 6. So this is, okay, so this is, I believe, individual assignments. Is this in the syllabus? Let's see. Hopefully it's in the syllabus. Okay, individual. Okay, so there's 6 assignments. So that's showing that basically each of these 6 assignments is equally weighted. So this sums to 100%. And that's worth half of your grade. And then the team course project 30%, midterm 10%, final 10%. So there's a total of 100%. So that's the breakdown for grades. Does that answer your question?
Yeah. Also another question. For the password cracking assignment, I think week 3 is only focusing on networking, and I think it's kind of out of scope of that week because, like,
yeah. So I noticed a similar thing. I think it's because the class moves at such a quick pace, since it's like half of a normal semester, which I don't know, maybe that's the standard on Coursera. But I think it's basically, I would definitely start taking a look at week 4's application security module before looking at that assignment. So let's quickly take a look at week 4. Binary hacking assignment, reverse engineering. Yeah, so this reverse engineering section is definitely going to be directly applicable to that. Yeah. So maybe it doesn't necessarily make complete sense why a non-networking assignment seems to be due during the networking assignment module, but yeah, I guess that's how it is. Hopefully this assignment won't be too difficult. It hopefully is easier than the backdoor web server. Certainly, I mean, that's, I guess, whoever time estimated it in that way. Though depending on what you're comfortable with in terms of different areas, maybe it won't be easier. I'm not sure. Yeah, so does that, I don't know if that answers your question, but that's definitely how it is.
Yeah, it does. One final question is it safe to actually use like AWS or like EC2 or any cloud services to like have a local, like spoon some machines and test like ARP spoofing or whatever we are being taught in the class to like do it there basically.
Yeah, so if you're setting up your own environment and you're attacking your own environment, that is definitely fine. I think there's some sort of ethics module that maybe digs a little deeper into that concept. But yeah, if you're set up your own environment and you want to mess around with like ARP spoofing and stuff, attacking your own setup environment, that's definitely totally fine.
Cool,
Okay.
thank you.
Yeah. Are there any more questions? Otherwise, I can demo something that I put up on the GitHub that might be useful for the web, the backdoor web assignment. Just a random sort of thing here. Okay, so I saw there's a question. This person says the password cracking assignment is not too difficult. I used GDB and it did not require a lot of prerequisite knowledge if you know x86/x86-64 assembly. So I guess maybe that is the prerequisite knowledge, or if you have that. But yeah, and someone said that Ghidra makes it pretty easy too. That's potentially true. So in my opinion, you don't need to use anything like Ghidra. If you, honestly, all you need to solve this assignment, when I initially took the course and solved this assignment, all I did was this right here, obj dump, and just start looking at the assembly. So if you just jump to main and just start reading through it, you can reverse it. It's not that many instructions. You can just like literally just get a piece of paper and just write out the requirements. People are saying the Ghidra makes it a breeze, so that's good to hear. But one thing to note, that if you are decompiling stuff, and I don't know, sometimes decompilers do crazy things that, in my opinion, in some cases, decompilation can be more confusing than just looking at the assembly yourself. So that's something to keep in mind. I think it's also useful to understand how to look at assembly yourself, but if you want to use Ghidra, go for it. So that's what I would say about that. But yeah, when I solved this assignment the first time, I just used obj dump. You'll learn as you start to reverse this program that there's basically some constraints on the input to determine whether or not your input is correct. And I just wrote out those constraints by hand and solved them by hand. Like, it's not too difficult, hopefully. But yeah, that's what I will say about that assignment. So someone said, I worked on week 3 for cracking the password. I found check password. Should I find a character, presumably like array or buffer, for the stored password? And then yeah, someone said the password is not simply stored as a string in the binary. It is a bit more challenging than that. Yeah, so there's not just, so for instance, if we run strings on recheck password, we can see that, for instance, there are strings in the binary like, hey, there's not enough R's, or this is an invalid password, or this is the correct password. So presumably you want to figure out how to make the program print this out, and then you have the correct password that I think you just upload to Coursera. I mean, maybe you might guess that that's the password. It's not. Like that, yeah. So the password is not just stored as a string in the binary. It does various assembly operations. Like for instance, it might check to see if the third byte is equal to hex 47, or I don't know what it does, but that sort of thing. It doesn't just have a string stored at any point. Okay. So something I wanted to show that might be useful for people still working on the backdoor web server is this like test environment thing that I pushed up to GitHub. This is not the AutoGraders test environment. This is something that I just wrote in like 30 minutes that I figured might show an interesting way of thinking about how to debug your program, or like think about your program, like slowly work out your program. And it's this test environment thing, which uses Docker. So if I look at the Docker file, so basically it's based off of Ubuntu 18.04, which is what the AutoGrader is based off of. It installs Build Essential, Netcat, and curl, which are useful for making your program and being able to communicate with your program. And then it creates this submission directory inside of your container, says we're going to work out of that. And then it adds this test.sh file, which I'll show next. It adds your submission.tar.gz, so like already tarred up. I believe that's the format that you're expected to submit as. And then it tries to make your assignment, and then it runs the test script. So that test script is relatively straightforward. It's got this function here that will start up your web server. It has this other function that will stop the web server. And then it just has a couple basic test cases. Of course, there's more test cases than this. And while developing, you could actually start writing your own test cases to make sure that your program's doing what you're expecting it to do. So for instance, these first two just make sure that the binary exists and that it's executable. This next one checks to see, hey, is my program listening on the port that it's supposed to listen on? And then this one just checks, hey, does it actually respond to HTTP requests in some way? Where that some way is like, hey, does it send me HTTP 1.1404? So if I run this, actually the other thing to show is this run tests.sh, which will do the following. It will tar up your submission. It will build the Docker container, and then it will run those tests. So if I run this, run tests.sh, actually I should probably zoom in a little bit. Whoops, run tests. So we can see that it went through, it tarred up my submission, it creates this Docker container, it runs some tests. We're currently, based off of what was pushed to this repo, we pass the exist test, we pass the executable test, but then we fail on these ones. And if we look at what we have, I should probably remember to zoom in on everything. If we look at this submission folder, which contains like kind of a sample submission, obviously it doesn't contain any actual code for making this work because that's kind of what you're supposed to be doing. We have a very simple make file. And I've noticed a lot of people are submitting like relatively complex make files that look like you'd probably like look up make file tutorial and this is what it tells you to do. You really don't need to make your make file that complicated. Like, so this just says that, hey, we want to update on normal web server.c whenever that changes where we want to rebuild. And then we just GCC it and say that the output file is normal web server. So this is a perfectly acceptable make file. It's pretty simple. It just does exactly what we're expecting. Obviously, make files and build systems can get way more complicated. And if you look for make file tutorials, it seems that potentially that's what they're suggesting you do. But I think that, especially if you never used make before and this is kind of like new to you, you really don't need to make things that complicated. This like 2-line make file is pretty sufficient. Okay, and then so the other thing is our program. Zoom in. Currently, it does nothing. So we saw that we were failing test cases. If I make the program just call system netcat listen port 1337, and the test cases are assuming that we're trying to run on port 1337, this will make it so we now pass that test case. Obviously, this isn't going to be a line of code that you're probably including in your submission, but just to show that, hey, we can run the tests and that will make a test case suddenly pass. Yeah, that does do that. And we can see some standard out when we use curl to talk to this, that this is what we got from curl. But of course, we're still failing this test case. The other thing, just in case it's interesting to you that I added, maybe this is cool, maybe it's not, is this auto run thing. So you'll have to install this enter, which you can just do like apt install enter, sudo apt install enter. And then I've already got it installed. What this auto run script does, here, let me move this here. What this auto run script does is that if I call auto run.sh, it first initially just runs it. We'll see, it'll go through all of our test cases. But now if I'm in my editor and I just like make a change and then I save that file, it'll automatically just go through and rerun it. So maybe this is useful for quickly trying to figure stuff out. Of course, if you wanted to like jump into like using GDB to figure out why stuff isn't working, this won't exactly work for you. If you're doing very simple, the classic very simple debugging of doing like, I reached this line by like doing like print statement debugging, it will work for that workflow. But yeah, so just something that I figured could be useful to people that are kind of new to working on programs, that maybe this is an interesting workflow for you. Okay, so that is all I wanted to demo for this. In terms of other things for this live session, are there more questions? Let's start with that people have. It doesn't seem like there's any more questions currently. Something then that I will randomly decide to demo here that maybe will be interesting. I was going to probably wait a little bit to start demoing this, but if there's no more questions and we still have 30 minutes, we'll just kind of randomly fill the time, then in a hopefully useful way. So if we look at this recheck password program. So I said that the way that I solved it initially was just using objdump, and that works great as long as you don't make any mistakes in reverse engineering and interpreting this. As soon as you start making a mistake and wondering like, why am I wrong? Like this makes no sense. This is terrible. Then things get more difficult. So obviously. So some other tool that might be useful to you for solving this, and also is going to be useful for solving other assignments, especially the binary hacking assignment, is Gdb. So if I launch Gdb with this recheck password, for those that aren't familiar, Gdb is the GNU debugger. I don't know if, I think that's probably what it stands for, GNU debugger. And it lets you basically just step instruction by instruction through a program, among tons of other things. So the first thing we do is we run Gdb, and then we can start the program, and then we can start interacting with Gdb to figure out what's going on. So there's all sorts of, so there's a question, is recheck password stripped? I have no idea, let's see. It is not stripped. Okay. So, what? Oh, we're still in that, okay. So I didn't quite show what I was about to do. Let's restart, okay, so start. So learning to use Gdb is basically like learning a whole language in and of itself. There's all sorts of various commands that you can do within Gdb. One of which is the examine instruction to Gdb. So this X basically is going to dereference some address and look at it. And then it's going to print it in different ways. So if I do, actually, before we get to the X instruction, let's start with the P instruction. So P is just for print. So if I want to print something as hex, so for instance, the RAX register, I can type, maybe I should zoom in a little bit more. Yeah, let's go with that. I can use P/X on $RAX, and that will tell me what the current value of RAX is going into this. I can ask for any register. I can ask for RDI, I can ask for RSI. In fact, since we're currently broken at main, which Gdb kind of automatically did, we're currently broken at the start of main, we can see these RDI and RSI registers. And as you get more and more comfortable reverse engineering a program, you start to understand how x86 works, you'll learn that there is a calling convention where the first argument of a function is RDI and the second argument of a function is RSI. And in the case of main, if you've written a C program, which now you have because you've written this backdoor web server, you know that the first argument to main is argc and the second argument to main is argv. So this is argc and this is argv since we're at the start of main. So the next thing to learn about, other than this P/X RSI instruction, is X, the X command, the examine. I think X is for examine, I'm not sure, but that would be my guess. Examine, which will basically dereference a value and then tell you the contents. So for instance, if I do x/x of this, and I think you need a star at the front, or maybe you don't, that would probably do another dereference. If I do x/x of this value, it'll tell me, hey, at this value, at this location, printing as hex is this value in memory. So at this point in memory is this value. Alternatively, you could do x/x RSI directly, which will tell you that. And then, so there's other ways that you might want to format when you're examining memory. So this is the way, this does a hex formatting. You can also do a string formatting. So if I do x/s RSI, why? Oh, right. So I was confused there for a second. I was expecting this to print argv0. But the thing to note is that argv is a double pointer. It's a pointer to a pointer. So what we actually have to do is, I wonder if I can do star RSI. Maybe not. There's probably some cool way to do it, but so another thing is we're just going to keep rattling off things that you can do in GDB, unless there's questions, feel free to chime in at any point. You can say, I think the G stands for like a giant word or something, which will print 8 bytes. So this gives us the full 8 bytes at this address. So if we then do x/s on that, it will give us argv0. So we can see that, as we said before, if we know the calling convention, we know we're currently stopped at main. We have RSI, which is argv. We have RDI, which is argc. If we look at the contents of that, there's a pointer. At that pointer is a string, which is argv0. And we would know then also that, so at this is argv0, argv1 would be 8 bytes later. And that is a null pointer, which basically that's how argv is terminated, that the next pointer is null, and then that's kind of the end of the list. So here using GDB, we've broken automatically at the start of main, and we've been able to inspect what argc is and what argv is. Okay, there's other formatters though. So I showed GX, I showed X, I showed S. You can also start printing instructions. So for instance, if we wanted to print 8 instructions at the current instruction pointer, we can do that as follows, like this. And that will show, hey, we're currently broken at the start of main, and these are the instructions coming up. So I prefer to look at x86 with the Intel syntax. So if we do this set disassembly flavor to Intel, so currently it is doing AT&T syntax, which I don't know, AT&T syntax is worse, but for some reason GDB likes that as the default. I think Intel's easier to read, so I'll set that to Intel. And now if I print it again, we'll see it in Intel syntax. And you kind of see there's differences here. Probably the most significant of which is that the registers end up getting swapped. So here we have RSP and then RBP, whereas here we have RBP and then RSP. But there's all sorts of other differences between the two. Okay, so this is the absolute basics of examining memory and examining registers using GDB. There's other things you can do. So it's kind of would be boring if we couldn't do anything besides examine memory. We can convince the program to step forward. So using the next instruction, ni command with GDB, we can go to the next instruction. And now if we print our instructions again, we can see, hey, the next instruction that's going to be executed is push RBP. And that's what I just said there is important to keep in mind, that this instruction that it's pointing to here hasn't been executed yet. This is the next to be executed instruction. So we just executed this NBR64, which is a security instruction that I don't know if this course will get into, but that's why that exists. Anyways, so what else do we want to show? You can set breakpoints. So for instance, if I wanted to break at this move edx 01. So maybe I didn't want to just like rapidly hit next instruction, next instruction, next instruction a bunch of times. So actually something else we'll show real quick is you can do like next instruction like 4, and that will jump 4 instructions. So there's lots of things you can do in GDB. But let's say we see this call is coming up and we just want to break at ptrace. So we could either break here. So if I do break at this address, it will break once we hit that address, or we can do break ptrace, but this is going to be a little bit different. This is actually going to break at the beginning of ptrace. So the difference being breaking before we call it versus whenever we hit the inside of it. So there's kind of 2 different things, but we'll show that you can do both. So if I hit continue, we can see we've got 8 instructions. So we're about to call this. If we hit continue again, we're going to be inside of ptrace, and we can see, hey, we're now at the beginning of ptrace. So we're no longer inside of main, we're inside of ptrace. And you can see that we've changed where we are in memory significantly. We've changed from this like 55555 place to this 7FFF place, which means we're just in this entirely different segment of memory now. Okay, so that is some basics with GDB. Before I continue, are there any questions? Nope, no questions. Okay, and feel free again to interrupt whenever, or message in the chat, whatever you want to do. Interrupt whenever. Okay, so what else should we demo? Yeah, let's actually demo something directly related to this assignment that might be a little trick. So before we do that, let's quickly run the assignment, or run the program. We can see that if we run it like this, it just says, hey, there's not enough args. If we pass an argument here, it'll just say invalid password. You could probably guess, just logically following from this, is that as we alter this, maybe eventually we'll guess the correct password here. Yeah, okay, so, but something to note actually, so let's run GDB again with this. So the first question you might have is, how do I introduce this argument here for guessing? And the way you do that is you type start, and then you can just like type the argument here. So like my guess. And we currently don't have any breakpoint set except for the breakpoint at main. 1 second. So if I hit continue, we're just going to continue till the end of the program, and we'll see what happens here. If we continue, it exits with code 01, which means basically someone called exit of 1, or passed 1 to exit, which is actually, we didn't necessarily show it, but actually, I don't know what this will return if we have an invalid guess. It might also return 1 there, which we can see like this. I guess in that case, it returned 4. Wait, no, it returned 0. Am I confused? I'm pretty sure it's $! Hold on. We don't use bash enough, apparently. Let's see here. I know I did. Okay, so that returns a PID. Pretty sure it's $! Then it's the exit code. Huh. 99% sure. Yeah, okay. That is definitely, or almost definitely true. $! People in chat are agreeing that it's $! Okay, got a little confused there for a second. So we can see here that when we do this and it returns, well, that's, why is it returning? Why is it changing? I have no idea why it's changing. Maybe this is something to look into, but we're going to ignore that for now and just continue on.
Depending on what's wrong, it'll exit with a different value.
As in which character in here is wrong? Or,
like
oh,
short,
if the length
long.
is not, okay, so there's all sorts, okay, and that's, okay, great, thank you for that All right, yeah, so it means at some point we maybe guessed the password length or something. I don't know. Okay, good to note, and something to look into further as you do the assignment. But we're not going to focus too much on that. What I wanted to show was that when we launch this with GDB, there's a bit of an issue. And that issue is that ptrace call. So actually, before we even do this, maybe something we want to look at is what is ptrace. So ptrace is a process trace syscall, which is how GDB is implemented, and basically how anything that wants to examine a program as it runs, a lot of tools that do that use ptrace in order to implement that. Yeah, that's basically all we'll say about ptrace. If you're interested in that idea, definitely look more into the ptrace functionality of Linux. Okay, but the thing to note is that we're calling ptrace inside of our function. Actually, the other thing we can do is show strace. So if we do strace of, not that, strace of recheck password, random guess, we can see that it does this ptrace and then immediately exits. So it never actually tells us that our password is wrong when we run it with strace or when we run it with GDB, which is us kind of trying to show earlier, which we'll show in a second here. It's calling ptrace, and then for some reason, it's like basically detecting that it's being debugged. And using GDB, you can like very easily get around this. There's a lot of ways to get around this, but we'll just show in terms of as an ability to demonstrate how powerful GDB is. One of the ways that you can get around this sort of thing is with GDB. So if we use GDB recheck password, we type start, we look at a bunch of instructions. We can break here. Yeah, so we'll continue. So we're about to call ptrace. So if we didn't want to, I guess another thing that I haven't showed yet in GDB, we've been using SI for stepping instruction. That will jump into this function and start stepping through this function's instructions. If we didn't want to do that though, actually, hold on, set, this is, whatever, we'll just go with it. If we didn't want to step through ptrace, maybe we'll just say, hey, ptrace is a black box. We don't really care exactly what it's doing. We just want to jump over it. Instead of using SI, you can use NI, and that'll just go over it. Okay, so we can see now we're about to test RAX. So another thing to note is that RAX in the calling convention is the return value of a function. So if we print RAX, we can see that it returned this 0xFFFFFFF. So that's interesting, maybe. And the thing to note with FFFFF is that that is -1 in 2's complement. So it returned -1 to us after we called that function. If we continue to step to see maybe what it's going to do after ptrace called -1, we can step, we can see that it does this test RAX, which is going to set some flags in the E flags register. I've never actually tried to print it. Okay, yeah, you can print the E flags register. Maybe this doesn't make sense, but one of the things that it contains as one of the bits in this E flags register, which gets set on these like this test instruction, which is how you do branching in x86, is a signed bit. I'm not sure which one is the signed bit, but one of these bits in this 286 basically says now whether or not RAX is signed, as in is the most significant bit in RAX a 1, which in this case it would be. So if we look at our current thing, we're about to jump if it's not signed. And where are we going to jump? We're going to jump to this address. So if we're not signed, so as in if this isn't negative, which means that the most significant bit of this isn't a 1, or probably most, the simplest way to think about it is this negative or not? If this is not negative, we are going to jump to main plus 65, which is right here. Otherwise, we're just going to continue executing. And you'll see that that means that if it is signed, which it currently is, we're about to call exit of 1, which explains why earlier on when GDB said exit returns 1, this is why. It's about to return 1 to, it's about to call exit with 1. Okay, so there's a question in the chat. Using TUI interface in GDB, TUI enable with layout assembly and layout ASM shows the registers, highlights the registers that change, and displays the flags in a human readable format. Yeah, so that is definitely a very good thing to point out. I haven't actually used TUI enable. We'll just try it. Let's see. There's probably a way to do like layout ASM. Okay, yeah, layout regs. So I haven't used this in particular, but there's all sorts of very useful ways of making GDB easier to use. I just wanted to first start by demoing just like vanilla GDB. So this is an interesting way of doing it with this TUI enable, which I guess is just built straight in. There's also all sorts of other things though, especially in the context of CTF. So for instance, there is this GitHub project called Debug that completely changes how it looks. So if we, you know what, we'll even just quickly demo it. It's kind of harder to look at when I have everything super zoomed in because less can fit on the screen. It's kind of trying to show you a lot of information. But we will do it anyways, just to show kind of real quick what that can look like. Right. So this right here in this repo shows you exactly how to set it up. And there's all sorts of other ones. There's also like GitHub GEF. There's tons of different front ends basically to GDB that kind of modify how GDB looks. We're waiting for all of this to install. Okay, so now we have, we should have GDB init, yeah. And this is basically how you can configure GDB. And I guess this just immediately sources some other file. But now if we run GDB of recheck password and we type start, maybe we need a dot now. What? Oh, we're not in the right directory. Go up 1. Okay. Makes way more sense. Okay, so now if we type start, you can see that there's all sorts of information on the screen. So now if I type like next instruction, we can see that it's actually just like displaying up at the top, like instruction by instruction as we go through. So yeah, there's definitely lots of tools that make GDB just like immediately more useful. And we'll stick to this. This is the one that I actually use most often, but as I said before, I wanted to initially show you vanilla GDB. Yeah, so we will continue though with Debug for the rest of this live session. So we will see, as we were saying before though, that we called ptrace and then we jump over this. We can see that we are testing REX. And in fact, actually the thing to note, if I had more, if I wasn't so zoomed in, you know, we can zoom out. We can see that we also have like registers and stuff. We have like all sorts of stuff. And it tells you whether a certain pointer is a like code pointer, a heap pointer, a stack pointer. It shows lots of stuff. And it also has additional commands built in. So if we look at, what is this? There's like some documentation somewhere. Documentation. There's like a ton of commands, and this is like built for CTF, so maybe it'll be more useful in the binary hacking assignment. Maybe you'll find some of these commands useful to you. But yeah, so there's lots of front ends for making GDB more appealing. It has other commands like this VM map, which will like print out all of the pages in memory, what their permissions are, what they're loaded from. There's lots of stuff. But we will continue with what we were going with here. Actually, how far do we want to zoom in? 1, 2, 3, 4, 5. We'll go with that. Okay, so we can still use the normal GDB commands. So as we were saying before, we're about to not do this. We're about to call exit. And we'll see that actually if we just continue stepping. Now we're back in the Debug display. We can see that now we're moving one into RDI or into EDI, and then we're calling exit. And now the program exited with code 01. If we start again though, GDB is extremely powerful. So if we, we'll just hit next instruction a few times. We could have set up a breakpoint. If we jump over this, and then, so right here, we're about to test REX. And we know that REX is -1. Or if we print it as hex, it's FFFFF. If we want to change what's about to happen, we can do that. We can actually directly modify memory and registers inside of GDB. So we can do set, what do we want to do? We want to set REX equal to, let's say that we want to set it equal to 1. Is this the right syntax? I think it is. Okay. And now if we print REX, we can see that now it's 1 instead of -1. So we can actually set the value of REX, which means that now when we go and do this test, we're actually going to take the other branch. We're not going to call exit anymore. So if we do next instruction, we can see Debug is actually trying to be like nice and basically not show us these instructions that we just like skipped over to and branched out of. But we can see that we didn't call exit. In fact, if we X8I from like here, we can see that this was doing the, why does this not look right? Oh, to, why does this look different? Let's just show a bunch of instructions from main. Okay, so we can see that ptrace was here. We did that test. We did our jump not the same. After we changed REX, we no longer executed these two instructions. Instead, we started executing from here. So you can see that we can bypass this ptrace check basically with GDB just arbitrarily changing the register value to make it no longer branch into this part of the code, but instead branch to the other part of the code. So now if we hit continue, we will get the message not enough args. So we actually are able to use GDB to debug this program. It's kind of the moral of that story. So if we, well, there's one more thing I was going to show. Oh yeah, GDB scripting. Oh, maybe I want to save that for the next one though. Decisions. Okay, I will very quickly show something related to it. You can actually script up GDB to automatically run commands. So for instance, if I do GDB-X, I believe it's -X is what's going to allow us to create a command. And I just say that I want to run C. That's not quite right. Start. Why? Hold on, let's oh, is it -EX? That's what it is. Oh, so if we do -X, this is going to be taking in a file. Actually, let's do it with the file. So like, let's say my GDB script dot, I don't know, .gdb password. If we run this, it's going to tell us again, no such file. But if we now go and create this my GDB scripts file, my GDB scripts.gdb, okay. We can type that we want to initially do start, and then let's just say that we want to continue. So now if we run this, it will just automatically start the program and go all the way. It'll just continue right away, so which means we'll exit. But we can arbitrarily script this. So anything that you can type into GDB, you can put into this GDB script. So what we want to do potentially, if we want to like automatically skip this ptrace, is that we want to break at ptrace. Then maybe, so the thing to realize with GDB is there's all sorts of commands and it's going to take you a while to learn them. But once you learn them, GDB is extremely powerful. So what we might want to do is break at ptrace and then we'll finish that function. And we can actually just do only this and we'll see. So actually we need to break at ptrace, and then what we want to do is continue the program, which means it'll continue until it hits this ptrace breakpoint, and then we can finish. And let's just demo what we've created so far. Is it showing that we finished? Oh, rare. Okay. So here's what happened when we did this. So we started the program. We immediately created a breakpoint. We're currently broken on main. When we type continue, we're going to continue to the next breakpoint. That next breakpoint is, that would finish. Hold on, let's test this. So let's see, like, what is current value of RIP? So when we run our script, where are we? Is it? Okay, I think the issue is like Pctf isn't showing us basically the last command to happen. We can see that we're currently here though. If I had to guess, and if I scrolled up, maybe it would show me. I'm not sure. Something's potentially interacting with Pctf and our script in a slightly bad way where we can't see the last command maybe. I'm not entirely sure. We could disable it, but we'll just go with it for now. Either way, though, we can see that we've scripted it where we start, break at ptrace, continue, we finish ptrace's function, and now we're at the instruction right after. So here, we could set RAX equal to 1. And then maybe we want to jump like 2 more instructions or something. Let's see what this does. Yeah, so it looks like x8i, RAP, or let's show from main. Let's show 20 instructions of main. So we can see that using this script, just starting GDB using this script, we have already done what we wanted to do, which was to basically bypass this ptrace check. And we're already now executing past it. So you could continue your analysis in this way by slowly building out this GDB script. And maybe as you're reverse engineering, you want to like break at a certain instruction and then print the contents of a register or whatever. And basically by doing this, you're slowly building up a scriptable, reproducible, like debugging run. And that potentially could be a very useful way of using GDB. So I just wanted to quickly show you this, several things in GDB, a lot of powerful, cool things you can do. And hopefully they will help you a little bit. Are there any questions before I start wrapping up this live session? And I'll push this also to GitHub. Well, if there's no questions, I am going to end the session. As always, feel free to email mcsonline@asu.edu or post in the discussion forums. In general, I prefer questions in the discussion forums, but if for whatever reason you have a reason where you don't want it to be in the discussion forums, I guess feel free to email mcsonline@asu.edu, especially, I mean, obviously if it's like a personal question, then send it through there. But in general, I definitely prefer questions being asked on a discussion forum. That way, if I answer it, basically everyone can see the answer. It's great. Is it live? So this is a recording, I believe, hopefully. I'd be very sad if it's not, but I'm pretty sure it's all recorded. And we will upload it to Coursera. I believe the previous one should have been uploaded to Coursera. I think they're somewhere in like week 1, presumably. There's like a live event at the bottom-ish, I think, and you can click on that. Okay, yep, so I'm going to wrap it up. See you all, and good luck with the assignments and the class.